Welcome. Let's start again. This is part 2 of C programming, and in this part we will see some examples. And before this part 2 there was a task to create a simple calculator. I hope that you all have created a simple calculator and you have some error in this. So in this video we will learn about some basic C character set or basic C things, then we will move to the calculator program. So basically C character set defines as a character denotes any alphabet, digit or special symbol used to represent information. So the C character set is divided into three parts, that is constants, variables and keywords. Now C constants are divided into two categories, that is primary constant and secondary constant. So C constants, then primary constant, secondary constant. Primary constants are divided into three parts: integer constant, real constant and character constant. Whereas secondary constants, there are many types of secondary constants, that is array, pointer, structure, union, enum, that is enumerated data, and all other things will be discussed later. First we will learn about primary constants, then we will move to secondary constants. Integer constants. It is a part of primary constant. An integer constant must have at least one digit. It must not have a decimal point. It can be either positive or negative. If no sign precedes an integer constant, it is assumed to be positive. No commas or blanks are allowed within an integer constant. It is defined as int. In previous example, when we have added two numbers, we have declared a and b as int. It means a and b will hold the integer constant in C. Examples are 4, 4554, minus 5, 445, etc. Real constants. A real constant must have at least one digit. It must have a decimal point. It could be either positive or negative. Default sign is positive. No commas or blanks are allowed within a real constant. It is defined as float. Today we will see this float example in our calculator program. In division we will need float. Example 4.6 minus 4.564 minus 985.4 987. Character constants. A character constant is a single alphabet, a single digit or a single special symbol enclosed within single inverted commas. Both the inverted commas should point to the left. For example, here you can see both the commas are pointed towards the left is a valid character constant, whereas this is not a valid character constant. The maximum length of a character constant can be one character. Example B, C and all the characters. So we have to keep in mind that this pointer should be in left direction. C variables. A variable name is any combination of 1 to 31 alphabets, digits or underscores. The first character in the variable name must be an alphabet or underscore. No commas or blanks are allowed within a variable name. No special symbol other than an underscore, as in this example you can see in underscore profit can be used in a variable name. So there are some variable names using underscore, that is C underscore variable, P underscore name underscore 12. We can use only C as a variable, as we have used in our previous program A comma B. All these are variables. Now C keywords. Keywords are the words whose meaning has already been explained to the C compiler, or in broader sense already been explained to the computer. The keywords cannot be used as variable names. There are only 32 keywords available: auto, double, int, struct, break, else and etc. There are 32 keywords, and we will now we will use int, float and char. Some will be used later. So first of all we will use these three C keywords. We will not be able to keep int as a normal variable or float as a normal variable. So these are predefined keywords. We will not be able to use these keywords in our program. Some basic concepts. In previous program we have used this sign before the variables to store the value, and we have used scanf, printf and main. So what are they? Let us discuss with some basic concepts. Note that the ampersand before the variable in the scanf function is a must. This is called in C as ampersand. Ampersand is an address of operator. It gives the location number used by the variable in memory. When we say ampersand A, we are telling scanf at which memory location should it store the value supplied by the user from the keyboard. Printf outputs the value to the screen, whereas scanf receives them from the keyboard. Main is a collective name given to a set of statements. This name has to be main. It cannot be anything else. All statements that belong to main are enclosed within a pair of braces. We have already used this type of braces in our program. We have to use this type of braces in everywhere where the program is running. Some basic concepts. Again, the general form of printf function is given as printf, then format string, then list of variables. Format string can contain F for printing real values, D for printing integer values, C for printing character values. For now we have used D for printing integer values, and today we will use F for printing real values. In /n is escape sequences, which makes a new line in the program. We have already used /n, and today we will again see some new things, that is slash then star, line statement, star then slash, or double slash before a line to make it a comment. Now coming to the simple calculator program. I hope that you all have tried to create a simple calculator in C using the previous knowledge that we have gathered by adding two numbers. Previously we have added two numbers and have taken the output. Now we will do simple calculator program. The process is same, but there will be some problems regarding the division process. As if sometimes we have to divide 10 by 3 and the declaration is in int, then the result will be 3, which is wrong. So either we have to declare float, then 10 by 3 will give approx 3.33333, that is the real or decimal value of 10 by 3. Otherwise we can use type formation using float in the int operation. We will see this in today's program, that is simple calculator program. So let's start the calculator program. So here the simple calculator program, that is, already I have told you that slash then star and then star then slash will make a simple comment, that is simple calculator program. These comments will not be compiled in the C program. Then also double slash will make a simple comment. This will not be compiled in the program. Now we are going to the program, that is the header file #include stdio.h, int main function, then curly brace on and curly brace off, and we are assigning these variables as int. Look there, previously we have used two printf statements and two scanf statements to add two numbers. Now we are using one printf statement and one scanf statement. In one scanf statement we are scanning two values and assigning those two values in two variables. Those two variables are A and B, and we are assigning the values to them by using one scanf statement. So the program size will be reduced if we can use this type of structures. Now from line to line analysis, int, add, sub, mul, div, a, b. So these all are the variables which are declared as integer variable. Now printf /n, enter the numbers. So we are asking to the user to input the numbers, and the user will input two numbers simultaneously by separating by enter to use in A and B. Addition is defined as add equal to a plus b, adds a and b and stores it in the add variable. So add variable initially don't have any value, or it may have some garbage value. We will learn about garbage values later. So now it is defined as the addition result of a plus b. Sub is holding the subtraction value, mul is holding the multiplication value, and div is holding the division value. And we are printing those values as follows: printf /n addition &d add, and likewise this sub, mul and div, and we are using return 0. So you can I think that you have write this type of program. So now we are compiling this, and it is asking us to provide two numbers. Enter the numbers. First of all, we will provide 10 and we will provide 3 separated by enter. We can see that the addition is right, subtraction is also right, multiplication is right, but in division, when we divide this, we will get a result like 3.333333, but here we are having division 3. This is not right result, so we have to create it as a floating point integer or real point integer. So we can do it by doing so, that is, all the things will be in float, that is float, then everything we will have to change. If as this is a float value, then here also we have to change this, we will have to change this, then this and this, and we will compile and run this. Now we can see that the result is perfect, that is 3.33333, but it will consume a lot memory, as float will take a lot of bytes rather than int. So what we can do to reduce the size of the program, it is to be said that whenever you will make a program and that will be in small size, then it will be accepted. So we will have to make this program small. We don't have any problem to have integer add sub mul. So the problem is mainly with the division. So we will make division only float, other than all are int. It was as previous. So dd, and as a and b are now integers, so we will add this in d format. So we have only problem in division, so we are deleting division from int and we are describing division as float. So float div, so the div variable is described as float. Now as a and b, both these two are integer variable, we have to make them float variable in this statement by using float b. This will make this division a float value, and this division will hold that float value. And as all these are integer, so we will have to keep it as d, and the last will have to be we will have to use f, as this is assigned as float, and we have created a and b from int to float in this statement. So if we will not use this, then what will be the problem? Let's see this. Execute, compile and run. The same example, 10 and 3, it will give us only 3. It is giving float value but not the exact result, so we will have to make this float. And now execute, compile and run. We will enter the same 10, 3, and yes, this is the result. So wherever and whenever we will have to use float, we will change the format, not the total format, as if we use the total format as float, then it will consume a lot much memory. So we will have to reduce the program size, then we will use, whenever we will need this, we will use this type of structure. So this is a simple calculator program that we can run from our basic knowledge. So I would like to tell you that after this in part 3 there will be some more new concepts, so please you follow the part 1 and part 2 to understand the part 3. For now today that much is there, and in part 3 there will be another discussion on C instructions and one new example will be there. Till then please see all this part 1 and part 2, and please share, subscribe and like this video. Thank you so much.